Aerosol particles in the air. The aerosol is the mixtures of dust particles and vapors in the air increasing the pollution index of the air. The aerosol particles collide with the gaseous particles in the air surrounded by all sides and divert their path after the collision and hence move in a random motion. Pollen grain in sugar solution. If you take a sugar solution and add pollen grains of shea flour, you will notice that the pollen grains will move in a random fashion in the solution. This is because as the pollen moves during germination by getting the required osmotic pressure condition, they tend to collide with the other pollens and the particles of sucrose in the solution. Dust. You must have seen the random motion of the dust particles in the emerging light. The dust particles are surrounded by the gas molecules from the air. As the dust particle collides with the air molecules, they diverge in the opposite direction and therefore the random motion of the dust particle is observed. Effervescences of calcium carbonate. The effervescence is due to the emission of carbon dioxide gas by the reaction of calcium carbonate with water or hydrochloric acid. The gas released out will come in contact with the air molecules outside and migrate and expand in the air in the zigzag motion. Boiling water. As the water acquires heat, the intermolecular bonds between the molecules break and molecules move in a random path till it reaches the top surface of the water. The molecules of the water gain the energy that is converted into kinetic energy and they start moving in the volume of the water. As the temperature rises, the Brownian motion of the molecules increases. Gas filled in a balloon. The gas molecules filled in the balloon collide with each other among the surrounding molecules and move randomly inside the walls of the balloon. The balloons are filled with helium gas. Since helium is light in weight, the gaseous particle floats in the upward direction up, collides with the wall and the other particles surrounding it. Electrical discharge in semiconductor. When the electron leaves its place and migrates towards the conduction belt, it creates a vacant space called a hole which becomes positively charged. The movement of the holes is in a direction opposite with respect to the electron. Both electron and hole show random motion. Carbon dioxide released from the burning wood. The wood is composed of a carbon atom that reacts with the oxygen from the air during combustion and produces carbon dioxide. The carbon dioxide gets mixed in the air in the atmosphere. The molecules of the carbon dioxide gas collide with the air molecules and thus the random motion is seen. Motion of electrons. The electron in the conductor moves in a random direction as it starts conducting. The motion of the electron generates electrical energy. The conductors have free electrons and when it is supplied with the energy, this energy is grasped by the electron and becomes agile in motion. Plasma. Our body is composed of plasma, and the nervous system works based on the electrical signal through plasma. The collision is also seen in the plasma matter and the motion of the plasma is just like the gaseous particle. The particles of plasma move in a random motion. Bacteria moving on water. If you have carefully observed the motion of the bacteria on the surface of the water, you will notice their zigzag motion of them. The bacteria can easily float on water and move against the direction of the flow of water. This may be due to the glucose polymers. Lime soda. You must have observed the effervescence and the opacity of the lime soda. The effervescence is due to the carbon dioxide gas released in the reaction of citric acid with sodium bicarbonate. As this gas is released, it moves upward direction to escape from the volume of the juice, but collides with the molecules along the path, hence the random motion is seen before escaping from the glass. Heating oil. On heating the oil, the molecule from the volume of the oil in a container starts moving in a random motion as the heat energy is converted into its kinetic energy. This creates friction between the molecules of the oil and increases the heat energy. Two gases mixed in the container. As the two gases are mixed in the same container, the molecules from both the gases will exert a force on each other to react. The two gases will show partial pressure depending upon their density and molecular masses. Winnowing. It is an activity performed to separate and blow off the husk and chaff from the grains produces in the field. The grains are showered standing in front of the fan. The wind blows the lighter particles in the air and the grains fall down in the heap collected on the ground. The lighter particles will move in random motion with the air resistance for long until it settles down on the ground. Evaporation. It is a process of giving off heat energy in the form of vapors from the liquid phase of matter. The evaporated vapors collide with the surrounding vapors and the air molecules mix along with the vapors. Hence the random motion of the vapors is seen. Smoke. Smoke is composed of carbon dioxide, hydrocarbons, and free carbon suspended in the air. These molecules interact with the air molecules in the surroundings, thus polluting the air index. The particles of the smoke move in a random fashion and spread across a large scale. Wind through fog. Fog is a condensed particle of vapor evaporated from the water bodies. If these water vapors condense further, the dew point is reached where the vapors condense back to form water molecules and fall back to the ground. As the wind blows over the fog, the molecules move in random motion due to the air resistance and the collision of the vapors. Vapors inside the pressure cooker. In the pressure cooker, the boiling point of the liquid increases as the pressure inside the cooker is higher than the atmospheric pressure. As the liquid starts boiling, the vapors get collected inside the pressure cooker. As this evaporated vapor possesses the heat energy, they move in a random motion by converting it into kinetic energy. Blowing air. When you blow the air, the volume of air becomes perturbed due to the air resistance incident on the volume ahead. The air is pushed away, and at the same time, the volume of air is mixed with the other molecules in the air. Radiation's incident on the object. The incident radiation carries an energized photon that collides with the surface of the object and gives away its energy to the particle present on the surface of the object. As the energy incident on the object rises, the internal energy of the object is perturbed and the temperature of the object rises due to increasing heat energy. Hence, this causes the random motion of the particles present in the volume of the object. Soap and water. The molecules of soap have two terminals due to which they behave as hydrophobic as well as hydrophilic in nature. Just like a magnet, one end of the soap molecules is attractive to the water molecule and another end is the water hatter. Due to this duality in behavior, the particle moves in a random motion and can separate the dust particle from the fabric. Gas. The gas molecules themselves show the Brownian motion. This is because the distance of separation between the gaseous molecules is high and forms loose bonds with each other. Hence they are able to move freely around and tend to collide with the neighboring particle, causing the Brownian motion. Frequently asked questions. Why do we see the Brownian motion? It is a random and zigzag motion of the particle which is unpredictable. The Brownian motion is due to the collision of the particle with its surrounding particles in the system. Upon collision, the particle diverts from its path and moves in a different direction at a different angle depending upon the direction of the path of the colliding particle. What are the factors governing the Brownian motion of the particles? The Brownian motion is based on the collision of the particles with one another in a system. The factor governing the Brownian motion are the density of the particles, the number of particles present in the system, size of the particle, viscosity of the medium, the temperature and internal heat of the system, and the distance of separation of the particle. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.